back, ready to keep on going with presentations. So next up is a fellow chain saver that I'm super excited to hear from. We have Lerna Jaborian, who is coming to speak on our Mina Rust implementation. She is the project manager for our Mina Rust implementation, and she spent several years working as a PM in the tech industry in Toronto before joining us in the blockchain world and coming to speak at ChainSafe. So super stoked to have her present, and I'd like to invite Lerna up to the stage.
Hello.
Hello, hello. Good to go. Hi. The floor is yours.
Let me just share my screen and get set up. Okay. All right. Can everybody see that? Yeah, good. Not yet. Okay. All right. Try this one last time. Okay. Let me try one thing and see if that's going to work. Sure. No. All right, one moment, guys. Sorry about this. I think maybe it's not allowing me to share the slides just because every time I click on share screen, it's kind of dropping back. So don't know if I need some authority to do this, but.
Yeah, so what about if you want to share your slides with me and then I can share them for you?
All
cool.
Right.
Give us just a second here, everybody.
All right, shared.
Cool. Let me get those real quick. Da-da-da-da. Let's see. Nope, we don't want to do that yet. Wait, did you email them to me? How did you share them?
Yeah, you should be getting an email giving you access.
Oh, yep. Okay. I have it. Give me just a second, everybody, and then I will be there. Okay, can people see my screen?
No.
Oh, it does not like that. Just a second. Maybe here. Let's send it to Tim, since Tim has been able to do stuff.
Tim already has access, or he should have access.
Oh, okay. Then I'm going to volunteer Tim.
One second, guys. Just give me 1 second while I try to find the slides. Did you share it with me, Lerna?
Mm-hmm.
Okay. Yeah, it just got linked in Arch.
Nice. All right. Sharing. Y'all can see my screen?
Yeah. Yes.
And still seeing? Yeah?
Okay, perfect. All right, so I guess I'll start. So my name's Lerna. I'm the project manager for the Mina Rust implementation. And I'm going to start out by maybe giving you guys sort of like what we're going to cover. So if we can, go to the next slide. Bit hard to see, but basically I'm going to give a quick intro of the team. Then I'll talk a little bit about Mina, their history, and give you guys some facts. Then I'll get into the actual implementation that we're doing, why we're doing this, and maybe why we're doing it in Rust. We'll talk a little bit about the milestones, and we'll also talk in detail about Milestone 1, which is serialization, and Milestone 2, which is block selection logic. So those are the ones we've been working on this year. So I can give you guys a lot more insights on what's been going on, and then we can sort of end it with some questions and comments. So yeah, to introduce our wonderful team, we have Elizabeth, who is in charge of implementation. Next, we have Raul, who is our team lead. There's Willem, who is part of our amazing solutions team here at ChainSafe. And two of our newer devs who have been hitting the ground running, Hailong and Xinwen. Next slide, please. Yeah. So this is maybe like a brief history for Mina. So it was founded in 2017 by longtime friends Evan Shapiro and Isaac Meckler. So they were called Code in the beginning. As I mentioned earlier, it sounded too much like another blockchain. So to avoid confusion, they switched it and became known as Mina Protocol. The idea these two friends had were looking at other blockchains, they realized as you're adding more blocks, things are getting bigger and bigger and bigger and bigger, and maybe to a point where you'd come a day where you'd have trouble syncing with the blockchain. So they thought about maybe having a super lightweight, super small blockchain, and that's where this idea came from. So now Mina is known to be the world's most lightweight blockchain at 22 kilobytes, which often gets compared to being the size of a few tweets. And it's also never going to get any bigger. So if you're wondering how that's possible, it's because they use something that we call zero-knowledge proofs, or ZK snarks. So what the ZK snarks will do is basically, instead of having the whole history of the block, it'll take a snapshot, which makes it super lightweight and small. Their consensus, so again, they touched on this earlier today, but it's called Ouroboros Samasika. So it is based off of Ouroboros Genesis, which was the successor to Ouroboros Praus, and this was created by the Cardano team. So I believe for them, it kind of checked the right boxes, so it had the right decentralization properties, but because Mina is sort of the first of its kind, being such a succinct and lightweight blockchain, there was still a lot that they had to change. So they sort of made their own and then called it Samasika because it means small or succinct in Sanskrit. A couple of the roles I want to mention is probably because it sounds different in other blockchains, and you probably won't see something like a snark worker. So there's block producers, which are the equivalent of validators. And the snark worker is the person that provides that snapshot for you that you need. And of course, their source code was written in OCaml. So this is sort of where we come in and why we're re-implementing everything in Rust. So yes, thank you for that slide. So I'll talk a little bit more about that. So why are we doing this? Well, having an alternative implementation for any network is good because it will increase resiliency and make it more robust. And Rust is a very developer-friendly language and probably one of the more popular languages in the space. So it was definitely a great choice. And having more people that can read and comprehend the code is great because, there's more chances of people contributing as well. So something else that we're working on this project is enabling in-browser environments. So Rust, again, is a great choice because it can easily target web browser platforms. It has great tooling to support syncing Mina nodes in a browser with the Mina nodes on the network. And the last piece of work that we're doing is we're building out non-validator nodes. You can also call these nodes non-block producing nodes. So we're sort of laying down that foundation and groundwork for when they will, at a point, want to make block producing nodes. And yeah, as I mentioned, there are 5 milestones, and 1 and 2 are the ones we've been focusing on this year, and we'll do the rest in 2022. So I'll just go through them quickly so you guys can understand what they're about. So Milestone 1 is serialization. So in this milestone, basically, we are using something called BrintProt, which is a serialization library. And this comes to us from Jane Street, which is a trading firm. And what we're doing is we're basically allowing 2 nodes to communicate with each other. Next, there's Milestone 2. Milestone 2 is block selection logic. So basically, you are allowing the network to know which chain to choose when there's a long range or short range fork. Milestone 3, block verification. So this is where that ZK snarks would come in. So you're sort of verifying the proofs in the blockchain. We would be building pieces to verify how to validate blocks and how to, I guess, verify transaction proofs on the Mina blockchain. Milestone 4. Milestone 4 is where we would sort of store and update the account database. So all the data will be stored securely. So we'd be building out the pieces to allow the Mina nodes to persist the blockchain states and ledger information in a database. And finally, we have the libp2p support, Milestone 5. So this is where we would allow the nodes to discover peers by using libp2p. So this would also support the submission of transactions via a gossip system, validate and support compatibility for those browser environments that I mentioned earlier, which would allow Mina to be accessed easily from pretty much anywhere. So let's jump to the next slide. Thank you. So Milestone 1, like I said, I'll start by maybe saying what serialization and deserialization is. So with computers, when we're talking about serialization, we're taking or converting objects into bytes, which then can be stored or transmitted. And when we say deserialization, we're doing the opposite, where we're reconstructing an object from bytes. So how we actually did this for our project, as I said, we used BinProt, which Jane Street developed. So this is coming to us from the high frequency trading world. So you know that it was something that needed to be fast and robust. And what we did is we tried as much as possible to stick as closely as we can to the reference implementation and make a perfect recreation of that in Rust. So we went through a lot of challenges because, you know, having such a complex type that has to be byte perfect is incredibly challenging. So our next step was to use something that we call Serday. Serday is just a Rust crate that we use to implement serialization and deserialization formats. And once we had that, we implemented a couple of traits that knew how to serialize and deserialize primitives. And then we added more traits that would help compose those into actual data structures like structs and enums. From there, we use what we called macros. So the macros you can use to annotate your own types, and that will automatically follow like a systemic procedure to generate a serializer. To generate a deserializer, you have to first make sure that you have all the types already implemented and annotated with this macro. So what we were trying to do at the time was to implement the types to match the OCaml implementation. And it had to be perfect, again, because if it's not, then your round-trip tests would all fail. So it was like this massive challenge to have, to re-implement everything in Rust from OCaml in a way that the serialization would be exactly the same. We also ended up, not yet. We also ended up writing our own custom Serday data model. And this allowed us to break down the serialized form of these blocks into smaller chunks and then test those smaller chunks individually. So we slowly worked our way up the type graph, which Tim, now you can move on to. And yeah, this is very complicated. So this is what the type graph basically looked like from a Mina block in OCaml. So yeah, big challenge, but very rewarding as well. Okay, we can move on. So Milestone 2. So this, like I said, is what Mina uses to select the correct chain. So there are long range and short range forks, so you have to be able to find a way to figure out which one would be the correct one. So we have three main pieces for this. The first one would be storing and buffering the blocks received from the peers. This helps in choosing the right chain by sort of seeing what's being broadcast on the network. And for this, we implemented a library that we call the block tree. So the block tree library will help in storing the blocks that are received from the nodes on the network. Next thing we did, and we are still doing, is implementing the checkpointing functionality. So checkpointing is basically how Mina figures out whether a fork in the chain is a long-range fork or a short-range fork. So it uses two checkpoints. They're called the start checkpoint and the lock checkpoint. So if the fork falls, let's say, within the range of the start or the lock checkpoint, it'll be considered a short-range fork. But anything before the lock checkpoint will consider a long-range fork. In this case, you'd have to use something that they call chain density to figure out which one is the correct chain. So, not yet. So the next thing I will mention is chain density. So that's the last big piece of work that we're doing. So what chain density is, there's a few components to it. So there's something that we call the critical window. So when you have an epoch, there are different sections, and the critical window is maintained by the chain, and that's what helps you calculate the chain density. So when we're talking about calculating chain density, what we're saying is there are different slots in an epoch, and there's something that we call a sliding window. So the sliding window will move from slot to slot, and it will calculate the chain density at a given point in time. And storing the minimum window density is what allows Mina to figure out which chain to choose if it's a long-range fork. And the way to do that is the valid chain will always have a higher chain density than the malicious one. So that's pretty much what we covered in Milestone 2. You can go on to the next slide. I want to sort of end the presentation by saying thank you to the Mina Foundation and O1 Labs, and particularly the people that we work more closely with that are on this list. So something that comes up in our conversations is how easy to work with and collaborative everybody is. So just want to say a big thanks to everybody. And that's it for me, Jimmy.
Awesome stuff. Super great. Thank you for the presentation. And thank you, Tim, for stepping up and sharing your slides. That was greatly appreciated. And so we have a couple questions that I want to run by you.
Sure.
The first from Dante is, were there other languages that you considered, like for instance, Go? How did you land on Rust?
I'm not sure if the client considered other languages, but I would say looking at all the different ones, Rust is definitely like the clear winner, so to speak, because of some of the stuff that I pointed out. It's just a really popular language, if not the most popular one in the space. And it also has really great features for what we're trying to build with this project.
Sweet. Yeah, Rust is awesome. We love Rust. I also love Go too, so we also like Go. So the next question would be, do you believe Mina will be lightweight enough to run a node on mobile devices?
Well, that's the idea, actually. So there are many different, I guess, like phrases you'll see on their website. One of them is powered by participants, and I believe one of them is like a blockchain that you can put in your pocket. So yeah, that's the idea, to have people access Mina through a phone, and it wouldn't even need to be a really high-end one. It could be just a regular phone. So yeah, definitely.
Yes, that's sweet. I love that. I find Mina particularly exciting, so I love this. Let's see. Okay, we have one more question that I see, and it's, do you plan to have the node work both in and outside of the browser?
Can we be more specific on that?
Maybe they could type more. My guess is because if it's a Rust implementation, it can compile to Wasm. So maybe thinking that it could be run in browser as well as like natively.
Yes.
I don't know. Maybe they have a bigger elaboration.
No, Wasm and ARM are part of what we're trying to build as well. So yeah, that would be part of that section that I was referring to when we're trying to build or enable in-browser environments. So yes.
And the big question, Do you have a formal project name yet?
No, we don't. We actually went through a lot of different ones, but I don't think we landed on one. So yeah, fellow chain safers, I'll open it up to you guys, but nah, we don't have one yet. Not one that we liked. And also there are a lot of really amazing Rust projects out there. So a lot of the ones that we wanted to use already existed. So far we do not have a formal name.
And also, if anyone in the community has thoughts on what we should name it, hit us up, let us know. We are open to suggestions. Well, Lerna, it was awesome having you on here. Thank you so much for presenting. Mina's amazing. You guys do amazing work. I'm stoked to see what the future holds. So thank you.
Thank you, Jimmy. Yeah.
Okay. So next up, our next presentation, my boss and friend. She is currently the head of protocol engineering here at ChainSafe. She is the implementer. Maybe people don't know this, but she is the implementer of ETH Monero atomic swaps, which is a super cool thing. She also wrote the Golang implementation for both linkable ring signatures as well as Snorkel signatures, which is amazing work. She's done extensive work on the ChainSafe products, both related to our Mina Rust implementation and our Polkadot host Gossamer, which is what I work on. In her free time, she likes to hang out with her pet rats, and she is very passionate about them. So feel free to ask her about her rats. And according to her Twitter, she's been keeping it vague since a while ago. I would like to invite up my friend, Elizabeth Banks. She's here somewhere. I know she is.
Hello.
Elizabeth, welcome. We are stoked to have you.
Yeah. Thanks for the intro, Jimmy.
Oh yeah. I have to not get fired. No, but so you're going to be here talking about Gossamer. Maybe for just a moment before, because I think we have a little bit of time before we get into that, could you tell us a little bit about the hackathon project you did recently and what is up with these atomic swaps?
Yeah, for sure. Yeah, so I started the ETH Monero atomic swap project at ETH Lisbon, so over a month ago now, I guess. I'm going to fill the comments. Sorry. Yeah, so I started that about a month or so ago. Been working on it since then. Recently tried it on the Arbitrum mainnet L2, which I think Dan posted the crypto news article about. So yeah, so got a news article. So yeah, just continuing developing on that. Yeah, I don't know. That's about it.
How did you end up choosing that as a hackathon project? Like why Monero? Have you been into Monero for a while? I know you're active in Ethereum and Polkadot and such, but how did Monero come into play here?
Yeah, I've been like a casual fan of it for a while, ever since I did my ring signature thesis project a few years ago. So
as the casual fan does.
Yeah, okay. But yeah, what's it called? Yeah, I got into like the ring CT and like all that kind of jazz around then. Kind of followed it, liked the tech, and then at the hackathon, Bitcoin and Monero atomic swaps came out earlier this year, so I was kind of inspired by that, I guess. And then for the hackathon, I needed an ETH-related project, and that wasn't implemented yet, so I thought it would be a good idea to start that. So that's kind of how it happened.
Well, awesome. Great work. It's the fact that you and other people also, but the fact you guys whipped that up in a hackathon is very admirable and just amazing work. And so I know you're here to present, so I'll let you get to that. And I'm excited to see what you have in store. So yeah, the floor is yours.
Cool. Okay, thanks, Jimmy. Okay, cool. Hello, everyone. So I'm gonna share my presentation to start off. So yeah, I'm just gonna start with, I think, can everyone see this? I'm gonna make it bigger. Cool, so yeah, I guess to start off, so yeah, I'm gonna start off with just a little intro about Gossamer and yeah, and kind of where it's at, like how it relates to Polkadot and that kind of thing. And then I'll go into a bit of a demo. So showing syncing Polkadot and Kusama and as well using the front end. So yeah, cool. So just to start off, so I'm Elizabeth. Yeah, I have been working at ChainSafe for almost 4 years now, working on various projects in my time. So I've been working on Gossamer for almost 3 years, I think. So since the beginning, so quite familiar with it. And yeah, just currently working on all the different protocol implementations we have going on. So yeah, so just to start, what is Gossamer exactly? So I don't know if there's been any Polkadot presentations thus far, so I'll just give a quick kind of Polkadot overview. So it's one from Moonbeam. Okay, cool. Well, I'll make it quicker then. So Polkadot is just an L0 kind of interoperability protocol. So you have like a relay chain, and then you have parachains that all have independent runtimes. And then they all connect to each other via the relay chain and participate in shared security. So yeah, it's kind of a nice way to have chains interop and all have shared security and cross-chain message passing and all that kind of nice stuff you want. So what is Gossamer? So it's a Go implementation of the Polkadot host. So the Polkadot host is essentially all the stuff that a Polkadot node needs to run that isn't the runtime. So what's kind of special about Polkadot is that it has a runtime, which is like the state transition logic, which is just a Wasm binary. So this can easily be swapped out. And also, yeah, so the Substrate blockchain framework, which Polkadot is built with, really I guess showcases this. So with Substrate, you can easily build your own blockchain just by plugging in a runtime. So yeah, so Gossamer is essentially analogous to Substrate in that regard, in that you can just plug in a Wasm binary runtime and kind of just run your chain. And as well, yeah, it's compatible with Polkadot. So you can use it to run a Polkadot node, or in the future, build a Polkadot compatible parachain. So yeah, so the two main kind of functions of the Polkadot host are for importing a runtime and easily launch a chain with custom logic. And then the second is just creating a Polkadot compatible chain that might potentially become a parachain one day if you want. So yeah, so the current status of Gossamer is that we can act as a Polkadot Kusama full node. So we can sync the entire network. Yeah, it's pretty cool. And then also we're compatible with existing tooling such as Polkadot.js and the Polkadot telemetry site. And then we're currently relating to our future plan. So our future plan is to interoperate with Polkadot as an authority node or validator node, so not just as a syncing node. So this will allow people to stake using Gossamer and to get rewards and build blocks, and participate in finality, and all that kind of good stuff that a real node can do. So so currently we're running an internal Gossamer DevNet with Gossamer only nodes, and then trying to fix all the bugs there and get that nice and stable. And then after that, we're going to move to the cross-client DevNet. So this will be Gossamer and Substrate together to test the authority functionality. And then after that, we'll hopefully be able to go on the West End testnet, and then eventually Kusama, and then eventually Polkadot. So yeah, that's kind of our roadmap there. Cool. And then a little aside, so the Polkadot host can't become a parachain on its own. You can use it to make a standalone chain, but it doesn't act as a parachain, as the parachains require some additional functionality that will connect the pair chain to the relay chain. So in Rust, this is implemented with Parity's Cumulus project, which kind of wraps Substrate and allows the Substrate node to become a parachain. So ChainSafe has received a grant from the Web3 Foundation to build Go Cumulus. So this will be a Go implementation of Cumulus. So this will allow Gossamer chains to become parachains, essentially. So yeah, you'll be able to, in the future, build fully fledged parachains with Gossamer. And as well, if you have a parachain and you want some alternative client, you could use Gossamer and Go Cumulus to have another client on your parachain. So yeah, so some of the kind of higher level project goals for Gossamer. One of our main ones is just becoming a modular blockchain framework that's really on par with Substrate. So yeah, so right now we're a Polkadot host, so we have all the functionality, I suppose, like in terms of like consensus and networking into the database, tree, etc. But we really want to make it super modular, so that's really easy to swap out the consensus layer, for example, which I believe Moonbeam has done. I think I got that correct. And then as well, being able to easily swap out things like a tree implementation or the database, and just like making it really well documented and easy for people to really use it as a framework. And then as well as just to increase client diversity in the Polkadot ecosystem. So yeah, so essentially alternative clients, like we want more than just one client running on the ecosystem for both like the relay chain and parachains. So yeah, that's kind of where Gossamer comes in. Okay, cool. So I will move to the demo section of the code, or of the workshop, of the presentation, sorry. So let me share and unshare. I don't know how exactly this is gonna work. I don't want to share my browser. Okay, there's some recursion happening, so I'm just gonna get rid of this for now, and if there's some issue, just like Jimmy unmute and tell me, please. Cool, okay. So I'm gonna make this bigger. So yeah, so the first thing I'm gonna show is just running a Polkadot or Kusama full node. Make this a bit bigger too, why not? So I'm just gonna go to the Gossamer repo, make sure I'm on the development branch, I'm up to date. Okay, I think I'm up to date. So I'm just gonna build Gossamer again. And then yeah, then this places the Gossamer binary in the bin folder. So running a Polkadot or Kusama full node is pretty straightforward. You can just start it with the -- chain Kusama or Polkadot flag. So I'm just going to show that to start. So yeah, I'm just going to run a Polkadot node. I think I was already syncing this before, so it's going to start not at Genesis. But if you run it for the first time, it'll start at Genesis. So yeah, you should see that it starts syncing shortly. So right now there's no peers yet, but it should start to grab some peers. Okay, here we go. So we have 10 peers now. And then sometimes it takes like a few seconds or a minute or so to start syncing. We should see that happening shortly. Okay, cool. So I'm on telemetry now. So you can see at the top, this is my node strategy witness. Yeah, my location, Gossamer, the version of Gossamer it's running, the current peer count. So 16, yeah, should be 18 now. The highest block on the chain, and the hash, and then this is the highest finalized, I believe. Yeah, so highest block, highest finalized. So I'll give it a second for it to start syncing. It's taking a bit longer than usual this time, but it should start shortly. Sometimes it waits till it gets like a lot more peers to start. So yeah, we'll see how this goes. Give it a minute there. markers do we have? Okay, it's taking a bit longer than usual. Normally it takes not this long to start. I don't know if I should like restart it or something, but all right. Oh, okay, there we go. Okay, I think it's starting. Yeah. Okay, cool. Yeah, it's starting. Okay, cool. I don't know why it was so slow. Maybe I have like some other weird stuff happening on my computer. Yeah. So slowly you'll see the block number creep up, and hopefully soon the finalized block will creep up as well. Yeah. I'll let it hang out for a while because I feel like maybe it's like around one of those. It's doing some heavy lifting, I think. That's why it's so slow. As long as that happens. Okay, I'll show Kusama now. Oh, CD. Say Gossamer. So for Kusama, it's the same kind of idea. You just run it with chain Kusama. And then let's go to telemetry. Okay, here we go. So it just showed up as well. So Mule Castle. So yeah, same kind of idea. You can see the head of the chain and the finalize and that kind of thing. Okay, I don't know why this is so slow. I'm gonna reinitialize it and start again. Because I feel like sometimes the chains can be a little, there's some sections that are heftier to sync than others. Cool. So let's give these a bit of time. Oops. I'll find the node. What was this called? Sponsor adopt. Okay, here we go. All right. So maybe this will start syncing shortly. Okay, whatever. I'll just leave them for now. Cool. Okay. So running a Gossamer development node. So I'm going to show running a Gossamer dev node and then just what's it called? Running the Substrate front end to interact with it. I'm going to put these away for now. So okay, so to run the dev node, you just run it with chain dev. I'm going to reinitialize it because I was running it before. So the dev node essentially is a node that's configured to have just one node running on the network, and this one node will build a block every slot and also just finalize blocks as well. So it's just like a standalone node that you can run. Oh, sorry. So start it with the WebSockets port for our front end. Okay. So yeah, so you just run it with the WebSockets enabled, and this allows the front end to connect. So yeah, so cool. So the Substrate front end. So let me go to that. See Substrate front end template. So I already built it. I put the instructions here, but I'm not going to rebuild it because I already built it. So I'm just going to start it. Oh my god, what happened here? Oh, I think it's the node version. Okay. Let's hope this fixes it. That would be concerning if it didn't. Okay, cool. It's just the version. Okay. Cool. So yeah, once it starts, it should look something like this. don't know if you can see this, it's probably really small, but you can do all sorts of interactions with the node. So yeah, I'll just wait for that to start and then show that. You can see like the dev node is just building blocks every 3 seconds or so. So that's cool. I'll just shove that over there. It's taking kind of long. I feel like I have some other stuff like running on my computer or something. It's causing it to be slow. Okay. Oh, okay. Okay, fine, it's starting. Okay. Let me check and see that the. Okay, maybe this server didn't start. Maybe because I have the other nodes running. Let me just kind of stop these for now. Whatever, I'll check them after. Okay. Come on. Bind already in use. Oh, I have freaking Nosh running. Okay, sorry, let me kill it. Oh my god, I can't believe this. Nosh got me. Okay, kill it. Okay, now it should work. Wow, okay. Yeah. Watch for the port conflicts, everyone. Okay, now it should connect, hopefully. Okay, cool. So yeah, okay, finally the front end showing. Okay, cool. So now you can see, yes, so it's connected to Gossamer, same version as before. It's current block, current head finalized block. You can check out the node runtime metadata. This is kind of for like the API usage. So yeah, it shows like what palettes and stuff are in the runtime. So the dev runtime runs just the Substrate default runtime, except configured to let the blocks be authored every slot. But otherwise, the logic is the same. So you can see also the dev node comes with a few pre-allocated accounts. So we have from Alice to Fruity, and they all have some mGOS. So I guess to start, I will just show transferring some mGOS, or some GOS. So the M is just the million GOS or mega GOS. So I'm going to transfer from Alice to Bob. I'll do 1 mGOS so we can actually see the units change. So 1, 2, 3, 4, 5, 6. Oh no, wait, this times that. 1, 2, 3. Okay, cool, let's try this. So if this, okay, cool, so it's in the pool and now in the ready queue and should be in the next block. Okay, cool, so yeah, so it was included in some block. We have the transaction hash, and we can see that the balance was moved from Alice to Bob. So yeah, so nice for doing some transactions and that kind of thing. You can also interact with all the palettes. So yeah, you can submit calls to the palettes, that kind of thing. You can query the palettes. So I can query, for example, let's check the current authorities, for example. So these are our current authorities. So there's Alice all the way to, I forget what the 9th one is, like George or Ian or something like that. Yeah, you can query the palettes. You can check current slot, that kind of thing. So yeah, our current slot. You can check for constants as well in the palettes. So you can check the epoch duration. It's 200 slots. Expected walk time should be 3 seconds. Yeah, so 3,000 milliseconds. We can also make RPC calls to the node. So yeah, I guess the reason that the Gossamer node just works with the Substrate front end is because the Gossamer node implements the same JSON RPC interface that Substrate nodes do. So you can, so you can just call, you can call all the same RPC methods as Substrate. So we can do, for example, we can try to get some block hash for some block number. Let's get it for like block 10 or something like that. And then, so we have the block hash now. And now we can query for like the full block, for example. Okay, come on, gonna work. Maybe get header. Okay, interesting. Did I copy pasta this right? Okay, so okay, interesting. I don't know why it's not working, but some of the calls work. So yeah, anyways. Cool, so I guess the last thing I can show is the runtime upgrade. So like I mentioned earlier, one of the big, innovative points, I guess, of Substrate is that the runtime is just some Wasm binary. So this Wasm binary actually lives on chain in the state tree. So you're able to submit a transaction to upgrade the state tree code, and as well that upgrades the whole entire state logic of the entire chain as well. So it's nice for some forkless state transition updates. So cool. So I'll show the runtime. So the runtime that I'm going to update is essentially, so I mentioned earlier the Gossamer dev node just runs the Substrate default runtime. So what I'm showing here is the Substrate default runtime, but I'm just going to change the name to be Gossamer node. So I'll quickly show the previous name of the node, or sorry, the name of the runtime version. So it was, so you can see that the name was Substrate node, and the implementation version was 0. So I just updated this to be named Gossamer node, increase the implementation version as well as specified in the comment. So I already rebuilt this already. I'm not going to build it because it might take a while. So so I'm just gonna, what is happening? Okay, so cool. I'm just gonna try to upload that, and then hopefully it works. So Substrate target debug rebuild. Awesome. Cool. And then I also put instructions in the doc that I'll share after on how to build the runtime as well. So if you want to, I don't know, try it out yourself, you can do that. Cool. So let's hit that upgrade button and see what happens. Okay, cool. So it looks like it's gonna hopefully be included. So it's in the ready queue now, and should be in a block shortly. Oh, okay, there we go. Cool. So as you can tell, a lot of stuff just happened. So yeah, so here we go. So the node detected a runtime code change, and it's upgrading at this block hash. So the previous code hash was this, and this is a new code hash. So oh no, I previously fixed this issue. Okay, 1 second. Okay, this okay, sorry, I fixed this earlier and I thought it got merged, but maybe it didn't get merged. Big yeah, this should be correct. Okay. I don't know why that didn't work, but I'm going to do that again. I'm just going to reinitialize it. Well, the runtime upgrade worked, but then it didn't like the new runtime for some reason, which I thought was fixed, but sometimes these things don't work as intended. Okay. let's try this again. Okay, cool. Let me just like do a quick transfer to see, make sure things still work. Okay. Constant, let's query that system version again. Okay, it's queried. Okay, I'm gonna try upgrading again. Hoping it works this time. Not sure why. I kind of didn't like it before, but okay, should be in a block shortly. Okay, cool. So it's now in a block. Gonna hope this works, but we'll see. Wow, okay. So this was fixed previously, and now it's not fixed. So whatever. I'm just gonna query the runtime version again. Oh, now it's working. What the hell? So it's like, okay, so it is still building blocks, but there's just a lot of error logs for some reason. Okay. All right, I'll look into that after. But cool. So I'm just gonna query the system version again, and it should be updated to Gossamer node. Okay, cool. Yeah. So now it says Gossamer node, and the version is updated from before. So runtime upgrade was successful. Error logs are just, I don't know, false flags, I guess. But yeah, so that's kind of the, yeah, that's the front end. So it's, yeah, pretty nice for, yeah, if you don't need to deal with all the stuff that Polkadot.js apps includes, such as like stuff for staking and like nominating validators and that kind of thing. I think the front end is really nice for just development purposes and just like easily submitting transactions and that kind of thing. So I would highly recommend using it if you're developing with Substrate or Gossamer. Cool. So I think that's basically all for now. Yeah, I guess I'll share this after. At the bottom of the link, I have another link to my previous talk I did earlier this year. That was like a bit of a longer talk, so there's a bit of extra info in there if you want to read it. But yeah, that's basically all. So hope you enjoyed. Let me. I can stop sharing now.
No, that was awesome.
Cool.
Like I'm literally on this team, and live runtime upgrades still blow my mind. So no, super awesome stuff. We have a couple questions. If you have a second to answer a couple of these.
Yeah, for sure.
So the first one, and I think you are the person to give insight to this, is how did ChainSafe come up with the name Gossamer?
Oh, yeah, I mean, I just came up with it. Like, I was reading a lot of books to find a good name for the project. And so I'm happy to say that the name came from William Gibson's Neuromancer, a classic cyberpunk novel. It's from like, so there's some sentence in there that has the word Gossamer, and I was like, wow, perfect word. I love it. So, yeah.
Beautiful. It's almost poetic.
It has the word go. That's all I wanted. So it's like kind of like an abstract word, I guess. It's like, yeah, it's one of those like unique words that you have in the English language.
Oh, yeah.
So I like.
Yeah. You're right. No,
Yeah.
That's amazing. Great stuff. It's the origin story.
Yes.
So the next question is, do you know if there are plans to build Substrate in Go?
I would say Gossamer is meant to be Substrate in Go. Yeah, like it essentially, yeah, in that way, yeah. So our current focus is more becoming like a Polkadot staking / authority node. But our long-term plan for Gossamer is to have it be like analogous to Substrate. So yeah, like you will be able to, yeah, kind of do all the same stuff with Substrate that you can do with Gossamer in the end. So in terms of whether there are plans, yes. So keep your eyes peeled for
Stay in touch.
Yeah.
Yes.
Yeah.
So the next question, great question. Are you to the point yet of benchmarking sync speeds versus the Polkadot client written in Rust?
Yeah, for sure. So the sync speed in Gossamer, we haven't like formally benchmarked it, but I don't know if you guys saw when I was like running the node, but it says like the sync speed, it just like logs it. But yeah, we have like some metrics, I guess, as well. But yeah, so this sync speed is a bit slower than Substrate at the moment. Not surprising considering, I don't know, we're Go and we're still like kind of in development. But yeah, I think the Substrate node, it also depends on whether you run an archive node or a full node. So Gossamer by default is archive, so it's slower. If you run a Substrate archive node and the Gossamer archive node, I think the Substrate node will be like, sometimes like 50 blocks per second, and Gossamer will be like, I don't know, 25 or so. So it's probably like half the speed in general, I'd say. But same order of magnitude of sync speed, I would like to say. So it's not like too far off, and I think moving forward we'll be able to hopefully reach Substrate speed levels. So yeah. And yeah.
Okay.
Compile time is way faster. Yes, as Dan mentioned, compile time is faster. So
True.
accounts for
Yes.
Yeah.
So then the last question we have on the board over here is, what has been the most difficult aspect of Gossamer's development?
Okay, yeah, great question. So there's been various difficulties, I guess. I guess at the first year or so of the project, I'd say it was the most difficult just because there was a lot of new technology that we were using that had literally like never been used for this before. So I guess one of the main ones I can think of is the Wasm Interpreter. So I don't know if you guys know, but Wasm and Go are like not really best friends. Like Wasm and Rust are definitely way more compatible. So there weren't really a lot of like Go Wasm interpreters. Like there's only really like bindings to like Rust interpreters, and as well like just it's not really like something that's documented, like using Wasm in the backend like this, like because it's mostly for browser. So it wasn't really, yeah, definitely like there was no documentation for like how to use Go like this to run Wasm. So that was kind of the one of the hardest parts initially, I'd say. Yeah, just because it was super new, no one really had done it, and yeah, it was just complicated, I guess. But yeah, other than that, I mean, the consensus stuff has been pretty challenging as well, I'd say, just because like running a authority node that performs all the like block building and finality votes and stuff can be, there's just like so much stuff that can go wrong, and like if anything goes wrong, like you just really don't want that to happen. Like you need the algorithm to be essentially like perfect to go on mainnet. So that's just been taking like yeah, it's been taking a long time. It's kind of been really challenging in that regard, just getting all of that kind of interoperable, I suppose. So yeah, those are the main challenges. It's kind of long, but yeah.
That's pick from the list. Well, great presentation. Thank you so much for joining us today. I'm super stoked to see what the future of Gossamer is. I'm on the team, so that's part of the reason, but I'm stoked anyways. So everyone should keep up with it. Keep up with Elizabeth. She does awesome work. Thank you so much for presenting.
Yeah, thank you, Jimmy. Bye.
Yep. Bye-bye. Okay. So real quick, I wanted to give a couple reminders. If anyone has questions, people probably pick up on this, but if anyone joined, please ask questions in the Q&A section during the presentations. We love questions. And we also have a networking floor located in the events tab, a drop down above me. So if you feel like trying to do some networking, feel free to hop on over there. But so right now, I'm going to introduce our next guest. It is Shapiro from the Mina Foundation. He is a graduate of CMU, where he got his BS in computer science and stayed to get his master's working in the CMU Personal Robotics Labs, which is super awesome. He worked as a software engineer for Mozilla and then went on to co-found and serve as CEO for O1 Labs and is now currently the CEO of the Mina Foundation. I am super excited for this presentation, and it is my honor to invite Evan Shapiro up to the stage.
Hello, cool. Thank you for the
Evan.
Hey.
Awesome. The floor is yours.
Cool, thank you. So first we're gonna try sharing a tab and see if it works. And it does. Cool. Okay. So when I was thinking about what to do for this, what to talk about today, one thing top of mind was some of the work that ChainSafe is doing on making it possible to have a Mina node that compiles to Wasm, which then can kind of work everywhere in a fully trusted way. And that got me thinking about what it would look like to actually kind of follow through on the full vision of this private verified Web3 world with Mina as like a backbone. So this talk is me thinking through what has to be done to actually make that possible. So I hope that is interesting to y'all. So what do I mean when I say private and verified Web3? I mean making crypto internet native without any additional trust assumptions. This means that we want to be able to build things as developers on the internet, and you use the internet as if it was a crypto application with all the trust guarantees that provides, all the privacy guarantees that provides, which seems like that's a very powerful set of primitives. We could do a lot with it once we have the set of underlying APIs. So I'm imagining a world here where users can use the internet without disclosing any personal information. They submit proofs of their information and some other ways of getting sensitive information on these applications without actually exposing the sensitive information itself. And they have tools to trust the information that they're presented on the internet is actually real in some sense. We kind of get this for free in a lot of ways on crypto. We know that the balances and accounts, for example, are backed by valid sets of transactions. It seems like there's probably some very powerful primitives you could build with this on the internet around seeing who in your social network, for example, has trusted certain web pages, or otherwise knowing the computations delivered to you by some centralized server actually are following some set of rules given in crypto. So, and for developers, this is also some pretty cool set of things we can do. We want easy APIs to be able to access this stuff. We could imagine with this that developer would be able to build an application without having to take hold of any confidential information. So if you imagine something like GDPR, they don't even have to take ownership of that sensitive information, so they can avoid having to deal with all those regulations while still getting to like the API solutions they're looking for in terms of the actual functionality. And also, I think with this, we could imagine things being fully censorship resistant, fully on crypto in a way where you deploy it, you kind of know the guarantees around how it will stay up. And I think that could be cool as well when you're thinking about deploying an application. So to give an example of what this could look like, I want to give a couple examples. So the first is anonymous voting for a neighborhood. So in this example, you're going to go to a website, it's going to send you a proof of the state of some vote that's going to happen. So it's going to say, this is a vote that's happening. Here's who's eligible to vote in it. Here's the status of it so far. And then you want to send an anonymous vote, proof of your vote and your physical address. So I want to say, hey, like, here's a proof I actually live in that neighborhood, but I don't actually want to, disclose this to this website where I actually live. And I don't want to disclose my particular vote as well. The application proves the result of combining everyone's votes. And then the site sends a proof of the new state, so you actually know what the result of the vote is. So that sounds a little magical. We'll get into how we can actually do this later, but just an example. Another example, kind of closer to home with the DeFi stuff happening right now. You visit a site, it sends you a proof. This is just more for fun, not necessary for this application. Some of your friends are using this service without revealing exactly who is using it, so you can trust it. You send the site a proof of your identity. And in this example, I'm saying your identity is registered with some mutually trusted third party, just because that kind of makes it easier to think through. There's probably ways around that. You then send the site a proof of your credit history, both off-chain and potentially on-chain, depending the state of crypto future, where there's some history actually built in on-chain in that future. So you can get the best terms that are revealing any of your information. So in this example in particular, you reveal proofs of things on and off chain, but not the actual information itself. But that's used so that they can actually decide what kind of terms to give you. You receive the loan, and the loan provider has some terms set up. So if it can prove that you were non-compliant with the terms of the loan with the zero knowledge proof, you actually can prove that you were non-compliant and versus the rules you actually signed up for, then it can go to that third party and get your identity out. Probably not I think eventually it'd be nice to end up in a state where that stuff didn't even exist, but maybe as like an intermediate solution, at least in this world, you have full privacy end to end as long as you're compliant with something that is on chain. So that's pretty cool. So what would we actually need to make this possible? So like I mentioned, ChainSafe is doing work on making Mina full nodes verifiable in Wasm, which is definitely a big part of making this happen. So that's in progress. That's cool. Having Mina applications and data fully verified in the browser. So this is kind of done through Mina's succinct zero knowledge proof. But to have actual applications work for this as well, we need some kind of actual application layer. And this is what OF1 Labs is working on with Snaps, which is in progress. And there's actually a workshop on for the ZK Summit in a few days. So that'll be cool to see a preview of that. I want to say the docs are also out for that either today or tomorrow, like it just happened. So anyway, that you can check that out if you're interested. In this world also, users don't submit their data, they submit proofs of data back to the application. So they don't send their credit score, they send proofs of things. And then also we're probably gonna need a lot of libraries for this. Some of these are in progress, things like handling data storage, submitting data, making it easy to write these Snap applications. So I put a little, kind of work in progress thing here because some of those are in progress. Some of those probably still need to be built. But I'm going to talk about these three right now in terms of ones that how this could actually fit together once we have it kind of all working. So the Mina architecture today is as follows. So you have some validators and they are one of them is elected to make a block. This is randomly by using their stake. They choose some transactions, they make a block out of it. They submit that block with a little checkbox, which represents a proof to the gossip net that is then added to the chain of blocks. And yeah, so that's basically how it works. We can imagine that we have to add on some stuff if we actually want this to work on the internet. So for one, if we imagine everyone's devices connecting to a single gossip net and sending around these full blocks, that might be a little heavy if there's a lot of these nodes connecting. I think we'll have to actually see what the performance is. Maybe this extra step isn't necessary, but at least here I have a parallel gossip net that only is sending around proofs of the Merkle root of the ledger and proofs of the consensus state. So that's a much more lightweight thing to be sending around than a gossip net. So maybe you could have a lot more nodes actually involved on this. So then after that, you have your device which connects to the gossip net. They know from the guarantees of the gossip net they're not being eclipse attacked, and they can actually get the strongest proof of Mina on the chains, which gives them a proof of the Merkle root of Mina. This then leads to them saying, okay, now I want to get the state of some particular account, say the account that has the voting information on it in our voting example. So now they have to do some API to request paths down from that Merkle root down to a particular account. And what's cool about this is these data providers can't lie about the actual state of the application because you know the Merkle root already. You can look at the path and you know if it's right or not, but they can withhold information. So I'll get to this potential protocol for this on the next page, where if you have n of these providers, as long as one of n is valid, you're good to go. Lastly, the client creates a Snap transaction in their browser by producing a snark proof just locally in the browser and then submits that back to the network. Then they wait a little bit and then the proof gets re-gossiped out with the new Merkle root. They check the state of the application and then they know that the new state of the application is. And what's cool is that they were able to do this in a way that's fully trustless from their own device, which kind of starts getting us to a state where we can do the things mentioned or the examples in the previous page. Here's a brief idea for a protocol that allows us to do the data providing in a way that is fairly trustless. Say there are n data providers that a client can talk to. We assume that at least one of these is responsive. We need one of n to be online for this to work. the web client locks X plus Y dollars with some conditions. If the client submits a proof from the data provider gets X dollars, the client gets back Y dollars. If the client does not submit such a proof at some time period, any data provider can, or anyone really, can submit a transaction that gets them the Y dollars and burns the X dollars. So then a data provider sends the client the account data and a proof of the data at the end of a Merkle path randomly determined by the requesting account. So this is something that no one has control over, this Merkle path. And presumably the client doesn't have it. If they had it, then they would probably also have the original data they're looking for. So it's something they need to get back from the data provider if they're going to be able to have that information. So the data provider knows that if it submits this data and the proof to the client, either the client will pay that back to the, will post that onto the blockchain and the data provider will get paid X dollars. Otherwise, the client will have, if it doesn't submit that, will have burned X plus Y dollars. Client probably doesn't want to do that. And again, the client probably can't make the proof himself since it doesn't have the random Merkle path. So probably some more needs to be written up on this, but basically there's probably some good ways that we can make it so that you can fairly trustlessly, as a data provider, know that you're going to get paid for providing data to a client. So I think with this, we'd actually be in a place where we can start building small applications that are serving small numbers of users. But this leads to another question, which is, if we wanted to do this in production at scale, what else would we need from Mina? So we would need much higher throughput, we would need instant finality, and we would need very low block time. Maybe you don't need all of these for all applications, but I was kind of thinking through, okay, what if we wanted to do this really at like what web scale? If we wanted to have all these things working, what would we need? So the Mina architecture today has some of the properties to make a smaller application that's more on the scale of what we see with Ethereum set today, but if we wanted to make it bigger, we'd have to improve some of these things. So Mina right now has only one producer elected per block, so it has probabilistic finality. You need a bunch of these lined up in order to have guarantees that any individual block is correct. It's exponential, so you get it pretty fast, but still probabilistic. You have about 1 TPS, and you have about a 3-minute block time. 1 minute of that about is the time to make proofs, and 2 minutes of that is the time to propagate this stuff over the network. So let's see where we can start improving some of these. So for next steps with Mina. So for one, if we want to have instant finality, instead of having it be that you have to look at many blocks with many different participants to get some certainty, we can instead elect multiple winners per block. So in this world, what we do is, instead of the VRF returning one winner, we have the VRF return multiple winners that then form a committee that then select a leader among themselves, and then that leader then produces a block. And then what happens is that block is finalized if you have enough committee members looking at that block. So that's pretty cool. I mean, this is like, a bigger change to the protocol. I'll get into I think, we need to basically embark on a project to start doing all these things, but this would give Mina this full functionality of instant finality with the additional properties I mentioned earlier. So, and then a path to improve throughput. So for one of these things, O of1 Labs is working on an improved networking layer, which will vastly increase the rate at which we can get things through the gossip net. So that should already be a big improvement. But another possible cool idea that we could do here, and something that there's already somewhat of a prototype being worked on at O of 1, is this concept of L1 level rollup pools. So you can have, instead of posting 10 transactions to the network, you can post a rollup for a particular account of 10 transactions where you post only the hashes back to the actual chain. And what this can let you do is push much larger volumes of transactions onto the network, where from the actual protocol perspective and the GossipNet perspective, you're only pushing one transaction, but that transaction represents many transactions that are rolled up. So this is somewhat, you can think of as rollups that are kind of native to the L1 in a sense, and can make it really easy for different applications to have their own rollups that then enable Mina to have much higher throughput in general. Let's say that with this improved networking layer and some other optimizations, we can eventually get up to, say, 100 TPS as an improvement. And then you can have these rollup layers that are each themselves doing very large throughputs. Then you can have the opportunity to have very, very high transactions being confirmed back to the Mina mainnet. So I think that's a potential route, taking advantage of rollups to do that. Lastly, we have the concept of improving latency. So right now, there's two things that are keeping this slow. One is that actual proofs of blocks are computed with each block, which adds a minute delay to producing a block. This is being reduced further. I think around on the order of 2x, so still maybe around 30 seconds. But even so, 30 seconds is still kind of a lot when you're thinking about block latency. The other half of this is the actual networking layer itself. Again, the new update to this should make it a lot faster. If this gets to a point where it's on the order of other networks around 10 seconds, we can imagine being in a place where it's around, let's say, 10 seconds to do the propagation and 30 seconds to produce the actual block production. Still 40 seconds, so we want to make that better. One possible way to do this is to defer the proving of each block until later. So each block includes a proof of a previous block, but not the proof for the current block. So you don't have to wait to make that proof. So you can see an example here. If we're making block 4, we can include the proof to block 2. So when block 2 is created, let's call that time 0. Block 4 won't get created until block 3 is actually seen at time 1, but that gives us between time 0 and time 1 to make the proof to block 2. So in doing that, we have this whole chunk of time where Snark workers can go and make this proof. So by the time it's actually time to make block 4, the proof that we need to include for that block for block 2 is all ready and everything, and we can just include it and then we're good to go. So with that, when block 4 is time to produce, it can just be turned out really, really quickly. It can go over the gossip net, and very quickly we can improve block latency, basically. So to kind of put this all together, we would want to be in a place with this where we have multiple people making each block, so we get instant finality. We have an upgraded networking layer so that we can have higher throughput and we can have better latency. Proving is also deferred for higher latency. There's higher throughput because we have these roll-up pools that allow us to have many transactions in one, and the networking layer is a little better. So between all this, we can start getting into a place where we can start achieving this end goal of websites that are fully verified end-to-end using Mina zero-knowledge proof and allow users to submit private data back to the chain. So, okay, so in summary, what does this all get us? So if we want to go back to this voting in the browser example, the user's client downloads the proof from Mina, and it does this by connecting to a gossip net, so there's no additional trust guarantees for consistency on top of the core protocol. And users get this entire proof of the application's particular history through Mina zero-knowledge proof. User downloads paths to the voting application's accounts. So let's go to the next one. So in doing this, they get pretty strong guarantees on data availability. If there's any of these data providers, as long as one of them are compliant with the protocol, you're good to go. User can submit their vote to the network with private information, so they can just submit proofs of their vote and proofs to the network, so they don't have to actually expose particulars about their identity or particulars about their vote to the network. And lastly, the network can process the transaction very quickly. This can be submitted to one of these roll-up application layers, which can put everything together and get it on chain at very high throughputs. We can have instant finality through many signers signing each block. And we can have low latency due to deferring the proving time and a faster networking layer for getting these proofs out to the network. So between all that, we can have applications that have all these properties together, which I think would be pretty cool. So in summary, clients can connect from the browser, from their phone. They get full access to cryptocurrency with all the guarantees you would want as if they were running like a full node. And they get privacy when they interact with the chain. Developers can take advantage of sensitive information without taking on storage and like privacy risks or having to think about the complexities of having to go through all the extra steps of making sure they're handling data in a good way that's good, because they don't actually even take hold of that data ever. It's all just running on chain in a way that's fully private. And also developers can get access to crypto infrastructure with very, very few trade-offs. It's all running in the browser. It's all running just from them being able to connect to Mina through all this extra stuff that would run under the hood in this future world. So yeah, I mean, this is something that I'm very interested in seeing if we can help make happen. I think, this is probably a multi-year vision, but something that if we can get Mina to do it, I think would just be really awesome to have, and as well like a good direction for Mina to go in. So if you're interested in Mina generally, here's just the general links you can check out the protocol on. The Twitter is probably the place where we post most things on. We're also looking for a developer advocate right now. So if you're looking to help build out some of these early Snap applications and help get the developer community going with what it would look like to be able to really easily build in JavaScript and TypeScript with zero knowledge proofs, you can check that out. There's a few other open positions you can check out too. That's all I have for this talk. Thanks for listening, and happy to answer any questions.
That's super awesome. Thanks so much, Evan. Mina is super exciting, even from what I know, even currently. So getting some insight into what the future holds for Mina and some of what the vision is yeah, super exciting. And we do have some questions over here. If you're willing to answer a couple of these. So the first one is we have, what would you say are the pros and cons of using ZK proofs for verifying off-chain data, as opposed to like an Oracle network reaching consensus on the data?
I think the main difference is that it's really nice to have the ZK proof part of it, because then you can have this privacy component. So I can prove something that has an Oracle, but also has privacy involved. So I can say, hey, here's a fact that is signed by my financial institution, but I'm actually only going to reveal the part of that that's necessary to use the application, not the actual underlying data, which is very important for putting things publicly on chain. I would say one advantage still of the Oracle system that I think will probably be temporary, but is the case at the moment, is latency. An Oracle network can come to consensus on something like a price feed much faster than you can produce like a bunch of proofs for it.
Curious, the follow up on that. You said you view that as a temporary thing. Why do you say that? Do you think like ZK will progress to the point where it can rival that latency?
They're getting a lot faster, and yes. So I think basically at some point it'll be like the challenge of coming to consensus on like this n-squared Oracle network versus just producing this local zero knowledge proof, and eventually that will get faster. It might take a while, but it's going.
Yeah, no, that's super awesome. Thank you for that. The next question is, in an ideal world, when you submit proofs of data, for example, a credit score, do you imagine the data is still stored in a third-party server like Experian, or is instead owned by the user?
I think it's kind of a temporary state that we are submitting proofs of things that will be on third-party servers, just because that's where the data is already. Eventually, it would be great to say, I've been interacting with this crypto loan protocol for a long time now. I built a reputation up. I'm going to show you my reputation is high without actually revealing the underlying data about those particular loans, for example, that I am working with. So I think eventually this will all be owned by the user fully. It's a kind of temporary thing where it's third-party servers.
Cool. Yeah, I mean, that makes sense to me, kind of dependent on where the ecosystem progresses, I suppose. That. So then, what part, if any, does Kimchi play in improving TPS and scalability?
Definitely helps a lot. So I want to say it's like 2x faster for proving and 4x faster for verifiability. So that just kind of for free gives us much faster block proving time, and it gives us much faster time for clients proving facts. And also the verification speed improvements mean that it's easier to scale TPS as well, because it's you can just verify more proofs in a shorter amount of time. So it definitely helps a lot with it.
Cool. So then 2 more questions on here. So the next one is, if I'm not mistaken, there's work going into an Ethereum Mina bridge. What do you think are the most impactful ways Mina can interact with the Ethereum ecosystem, or whatever other ecosystem it interacts?
I mean, I think we're going to see things be very cross-chain. So I think, as an example, we could see a DAO that is deployed on Ethereum leveraging this voting scheme I've talked about for it to be able to get anonymous, like censorship-resistant voting without having like very, very efficiently and easily. So this is a world where the Ethereum DAO says, okay, like we want these set of voters to vote on something. Mina creates a proof on its side saying, hey, like here's the result of that proof as a snap, because Ethereum can fully verify Mina, the Ethereum DAO can then go back and say, okay, I've seen this proof on Mina that says this is how everyone voted on this DAO vote. I can then apply the action of that on the Ethereum side. I think we're going to see like a bunch of composability things like that.
I definitely agree. I think that's a super exciting topic, and I'm very curious and excited to see how that unfolds personally. So then the last question that we have is the thought experiment. I think that's what that meant to say. High numbers of consumers start deploying their own cloud clusters to host their personal graphs and run automated tasks. Would this scenario shift some of your objectives or architecture?
I think actually be very compatible. I think what would be really cool about this world is you would probably still want some kind of state layer. And this is probably actually the world we're kind of imagining, where we're imagining your own device is where your own data is owned and stored, but you still have to interact with some kind of public kind of universal state for coordinating with other people when you're building applications. So in that world, you would take the thing in your private the little node, which we're imagining right now is your computer, your phone, or whatever, but eventually could also just be something hosted. And you produce a proof of it using zero knowledge proofs, and you submit that back to this kind of shared blockchain. So I think that those worlds are very compatible, and I think that the best actually they're kind of both happen and work together.
Awesome. Well, hey, thank you so much for joining us. That was an amazing presentation. I'm sure everybody here got a lot from that. We'd love for you to hang out. We know you're a busy guy, but thank you so much for giving us your time.
Thank you. No, it was great to be on and chat about stuff.
Sweet. Take care. And so we're going to do another quick departure to the floor mode real quick to make sure the YouTube live stream stuff is all good. Like resets sometimes, so we have to check in on that. So everyone bear with us, hang around, and we'll be back. Yeah, we'll be back. I loved all these presentations so far. Have been amazing. So I'd just like to give another thank you to everyone that's presented, and everyone else should hang around for future presentations because we have some great ones coming up. Let's see. Let's make sure that we're all good with the YouTube stuff.